This video is on factoring. We're not going to go into all types of factoring. We'll save some of that for later units, but we're going to review factoring that you learned in Algebra 1. I'll actually go through all of the steps to factoring and then tell you the things that we're not going to be worried about at the moment. Step number 1, always look for the greatest common factor. Always look for the greatest common factor. There are times when there isn't a greatest common factor other than 1, and that's cool, but you always have to look for it because if you're factoring something completely, you want to look for the greatest common factor. Number 2, look for any special case that we might be dealing with. So there are 3 special cases that I'm going to talk about. One we'll actually look at, and that's the difference of 2 squares. So the difference of 2 squares is when you have something that looks like a squared minus b squared. You can rewrite that as the product of a times b times a minus b. So that's something that you probably learned before. The difference of 2 squares is something you have to be on the lookout for. The difference of 2 cubes is something we'll do later in the year. I'll write it real quick, but just so you know, or you can also do the sum of 2 cubes as well. So a cubed plus or minus b cubed can be rewritten as a plus or minus b times a squared minus plus ab plus b squared. And we will use the acronym SOAP to describe that. Once again, you do not have to worry about that. I'm just putting it on this video, so if you ever come back and look at it later, you will see it later in the year. And then finally, factor by grouping. Again, this is something that we don't really have to deal with right now, but if you have 2 groups, you can end up grouping things and then factoring it based on that. But once again, that's something that we're not really dealing with right now. And then the final thing is what I like to call double parentheses. And the double parentheses is something that we constantly are looking for when we are factoring trinomials. So what this ends up being is when you take a trinomial and factor it into a product of binomials. So a trinomial has 3 terms, binomials have 2 terms. That's something that we will do a lot. Okay, let's take a look at these problems. Once again, if you struggle with something, press pause and then go back and write things down. Number 1, x squared minus 5x minus 24. So there is no greatest common factor. It's not any of the special cases, so I'm going to go double parentheses. X squared can only be written as x and x. There's no other way that I can take x squared, break it into 2 parts, and multiply it together. So that ends up being pretty simple. 24 could be 24 times 1, 12 times 2, 8 times 3, or 6 times 4. Those are all options there. But what we have to end up figuring out is how can I get a negative 5 in the middle? And I can get a negative 5 in the middle if I have minus 8 and plus 3. I can always check my answer by distributing it back out. So if I use the distributive property, x squared plus 3x minus 8x minus 24, that ends up being minus 5x in the middle. It ends up working out. So my answer is x minus 8, x plus 3. Could I write this equivalently as x plus 3 times x minus 8? Yes, I could. So if I change the order of the x minus 8 and x plus 3, that would not affect my answer. Number 2, once again, there's no greatest common factor. It is not a special case, so I'm going to go to the double parentheses. 6x squared could be 6x times 1x or 3x times 2x. But 5 can only be 5 times 1. That's the only way that I can ever write 5. So I'm going to write a 5 here and a 1 here. That's the only way I can ever do that. Could I write 1 and 5? Yes, I could. But since this is prime, I'm going to focus on filling that one in first. Uh, the vocabulary I use for that is lock it in. If there's something that's prime that you know works, lock it in. So that's what I did over here. I locked in my x's and then I kind of figured out what would go after that. Okay, so now I have this 6 and 1 or 3 and 2, and I got to kind of figure out how can I manipulate my way into getting a minus 13. So I can try a variety of different things. If I try, for example, 2x and 3x, and I multiplied everything out, I know that this is going to be 6x squared because I only put options that are going to make that work, and 5 and 1 is definitely going to work. So really, all I have to do is check to make sure that the middle terms are going to work out. 5 times 3 is 15, and 2 times 1 is 2. That works, right? Because 15 minus 2 gives me 13. So this ends up working out. I just have to make sure that everything is put in proper spots. So if I put a minus there and a plus here, that ends up working out. So I have 2x minus 5 times 3x plus 1, and I end up with the right answer. Now, what if I tried 3x and 5 and then 2x and 1? Well, if I look at this, that's a 10, that's a 3, that 10 and 3 does make 13, like negative 10x and negative 3x ends up making negative 13x. But if I look at this carefully, I would have a plus 5 at the end if I did this one. So this one does not work. It's close. It gets me everything I need. It gives me a 6x squared, gives me a 13x, gives me a 5. But that 5 ends up being a positive 5 if I did this and not a negative 5. So I need everything to match perfectly in order for factoring to work out. And then if I tried 6x and 1x, that would have, it would have not given me the right answer. Okay, so if I look at 13x squared minus 52, there is a greatest common factor in this problem. It is 13. So if I factor out the 13, I now end up with x squared minus 4. That is the difference of two perfect squares. So remember that a squared minus b squared can be rewritten as a plus b times a minus b. So in that case, I can rewrite this as x plus 2 times x minus 2. And this is my final answer for number 3. If I look at number 4, I'm very tempted to do the difference of two perfect squares. But that would be incorrect. I would not have looked at the greatest common factor to start. So if I look, there is a greatest common factor in this problem, and the greatest common factor is x. So if I factor out x, I end up with x times x minus 4. That is my final answer. I don't have to do anything else for that problem. I can't factor x minus 4 any further. Let's take a look at number 5. There is no greatest common factor. 3, 5, and 12 all don't have a greatest common factor. 3 and 12 do, but then the 5 kind of makes it not work out. I can lock in 3x and x because 3 is prime. So now the difficulty becomes what to do with 12. 12 times 1, 6 times 2, 4 times 3. So if I'm looking at this, I have 6 options that I can deal with. But there is something that we need to pay attention to. And if you do this, you will be much at a high, very big, I'm speaking crazy talk right now, but you will have a huge advantage. I cannot put 3 here. This is not something that can happen. I cannot put 6 here. That's something that just can't happen. And I can't put 12 here. Those are things that all cannot happen. And the reason why is because if you notice, 3x and 3, 3x and 6, and 3x and 12 all have a GCF. 3 and 3 has a GCF of 3. 3 and 6 has a GCF of 3. 3 and 12 has a GCF of 3. If the problem did not have a GCF at the beginning of the problem, if it had no common factor at the beginning, there's no way it can have a common factor at the end. So that reduces my options. It cuts them in half. I now don't even have to try any of these options. So that's really good. That's a huge benefit. Remember, there was no GCF in this problem, so I don't even have to think about those as potential options. So I have 3x and x. So I can try 4 and 3. That's okay, because the 3 is not matched up with the 3. And if I look at this, I have 3 times 3 is 9. 4 times 1 is 4. 9 and 4 I can manipulate to get 5. So this ends up working out. So I have 3x plus 4 times x minus 3. That works. Number 6 is not factorable. There's no GCF. And if you look, it's the sum of two perfect squares, which is not factorable. We will factor it into the complex numbers in chapter 3, but that's not something we're doing right now. Number 7. In number 7, I definitely have a greatest common factor. It is 4x. So notice 4 and x can go into all of these things. So 4x squared minus 16x plus 15. Now in number 7, this gives us a little bit of a problem. I do not have anything I can lock in. So 4x squared and 15, neither of them is prime. And that's a little bit of a problem, but what that basically means is I now have to go into double parentheses mode since it's not a special case. And I basically just have to give it my best guess. So if I try 4x and x, now I can look at 15 times 1 or 5 times 3 and try and see if any of these things works. None of these numbers has a greatest common factor with 4, so there's nothing I can eliminate right away. But let's take a look at this. If I put 15 over here, and the other thing we can notice is I can lock in the fact that both of these are going to be minus signs, because this ends up being a plus and that's a minus. So the only way I can possibly get that is if I have two minus signs. So I can lock that in. If I look at this 15, that's definitely not going to work because 4 times 15 is 60. That's definitely not going to work. If I put the 15 over here, that's also not going to work because 15 times x and 4 times 1, and I add them together, I end up with 19. So that's not going to work. 5 and 3, that actually gets me kind of close, but it's 17, and I need 16. So that's not going to work. And likewise, if I tried 3 and 5, that also would not work. So I'm going to try 2x and 2x. So this is just something I actually knew the right answer beforehand, but it's important to show on video that if you don't get it the first time, that's okay. You can try things until they work. So what if I try this? I get 10 and 6. Negative 10x minus 6x gives me negative 16x, and this ends up being a winner. So 4x squared minus 16x plus 15 can factor into 2x minus 5 times 2x minus 3. That works out great. Do not forget the 4x that you factored out at the beginning. Number 8, there is a greatest common factor here. It is 7x. So now I have 4x squared, or I'm sorry, 4x minus 5. It's not 4x squared anymore because I factored out one of the x's. 4x minus 5. This is my final answer. There's nothing else I can do. One last thing that we need to note is that not every trinomial factors into a product of two binomials. If I tried to factor this, nothing would work. That is why you learn the quadratic formula, because if you wanted to find out where that crossed the x-axis, it ends up crossing at something that's not a nice rational number, and therefore I had to use the quadratic formula to get it.